bypass air to here. So this is bypass air. Okay. This is coming from heat exchanger into here. So down into superheater to heat it up to 360 during production and 400 degrees during sterilization. Okay, so two temperatures here. So then the hot air out, this is three phase, 330 volts AC. Okay. Thermocouple here to measure the temperature, of course. These connections here now are much more reliable than what they've been in past years because of the heat. We used to get a lot of problems here with cables burning. Now they've upgraded this, it's much, much better. Since TBA 21, TBA 22, A3 platform, this has been much better. On the old machines, we have big problems with these connections. Yeah.
The same as TBA 22?
Same as TBA 22. Then the air out here, so this is out, but this goes virtually through the heat exchanger again, but to the preheating valve. So this air coming out during heat sterilization is not uncooled, so it's uncooled during sterilization, but during production it is cooled to have an aseptic chamber temperature of 78 degrees. Okay? During production, the air coming out of here, heat exchanger controls. The heat exchanger valve controls the airflow through the heat exchanger to keep the temperature in the aseptic chamber at 78 degrees. Okay. So this is the superheater.
So it goes out through the heat exchanger again.
Yep.
June?
Yep.
From the heat exchanger, where does it go then?
From here?
No, on the
to the preheating valve.
Oh, okay.
To here. Okay.
Oh, I see, yes.
So this is drawn a bit funny here, crossover. So out to the preheating valve here, and this is the preheating valve. We'll learn more,
Thank you.
about all this here, what's going on. At the moment, we're just talking about the components, okay? The major components of the sterilizers. So superheater, heat exchanger valve. This bypass, this one. So the first one.
So their bypass is either one or the other. They all work through
This one here.
Yeah.
Heat exchanger valve in heat sterilization is in full bypass. We have no air going down here at all.
Okay. Yeah.
So in heat sterilization, all air coming this way. In production, we have some air coming this way.
Oh, okay.
And some air coming this way. Remember when I opened up the window, it said 39 0 and 100% setting? So we said that when it is fully this way, it's full bypass, full heating. Then when it's fully this way, then it's in full cooling. But we'll cover this more, okay? But as the superheater showed, this one was bypass. This is air in from the heat exchanger valve. This is air out to preheating valve. Okay, so then the next picture you should have, like this. So this actually shows the positions. So here, heat exchanger valve is in normal operation here. So it's somewhere between full bypass and normal, okay? Controlling the temperature in the aseptic chamber. So we break this down a little bit more. Then here we show in cooling. So minimum cooling here. No bypass. Here. No bypass to the superheater. Here. So this is in cooling. Then this one here is in full bypass. So no air to the heat exchanger. So this is maximum heating. So this is heat sterilization. This is minimum cooling. Here. Right? Sorry? Maximum cooling? Yeah, sorry, maximum cooling. Maximum cooling. So the heat exchanger valve is connected to a stepper motor here. So the stepper motor will move to a position depending on the temperature of the aseptic chamber temperature. Okay? So the aseptic chamber temperature controls the position of this. So the aseptic chamber temperature controls the position of this. To go to more heat or more cooling. Made a comment here. The comment was digital output. Okay. 1 is forward, 0 is backwards. So for the stepper motor. So 1 is forward and 0 is backwards. And I made another comment. Inlog input and percentage. So this is what you're reading on the screen. Remember, when we open the screen, you see the percentage. Fully open 10 volts, 100% maximum heating. 0 volts, fully closed cooling. Okay, so this is what's coming back. Okay? Alright? The spraying nozzle. Sits here. This is the spray nozzle here, and which is connected to the hydrogen peroxide spray container. Hydrogen peroxide spraying container here. This is that safety valve I talked about. This is the air valve. We have another valve. We'll talk more about this. Okay. So that's if two could say it. So on one side we have air, and the other side we have peroxide. This is the spray nozzle. Spray nozzle is connected to the spray container. Okay. So here we have the spray nozzle. So on one side we have air, on the other side we have peroxide. We'll pull this apart because this is something you're going to have to do often. Okay. So when the compressed air comes in and the peroxide comes in, we come to this venturi here. When we pull this apart, you'll see how all this works in here. Okay, so we have a gasket here with holes in it. The gasket allows air to come in. As the peroxide comes out, there's some venturi effects here, and then we create this spray. Onto all these ball bearings. 90 ball bearings. This is the spray generator. When we spray peroxide to all these ball bearings are plus 300 degrees C. Be fucking hot. Okay? When the air and peroxide hits the ball bearings, we have an explosion. Evaporation of the peroxide. Then we push the peroxide through all the pipework from the machine and into the aseptic chamber. Okay? Remember I said one day out there, spraying, have a look, hydrogen peroxide, condensation all over the doors, everywhere. So this is what happens during spraying. If you remove this, do not mix these up. It will not work. You will get an alarm. Okay? Peroxide spraying incorrect. Then you go to venting for 15 minutes. Then you have to do restart. It's not CIP, just have to restart again. Don't do CIP if you've introduced product. So do not mix this up. We'll pull this off the machine. Have a look. Okay. This is the same on the flex as the same on the speed. They're all the same. These models. Same. Then we have the changeover valve. The changeover valve changes airflow between the aseptic chamber here, the aseptic chamber, or to the air knife. When you start the machine up to preheating, this checks itself straight away. It's one of the checks of preheating. You'll hear them. If the position is wrong, you have an alarm, the machine steps down. Okay? So this checks itself, this valve. So depending on the airflow we need in the machine, these valves will be in different positions. So here we have little airflow into the aseptic chamber. Here we have a lot of airflow to the air knife. Here we have a little flow to the aseptic chamber. Here now we regulate the air coming in from the preheating valve. Okay? From the preheating valve. Here, preheating valve. Okay, this is to the aseptic chamber. This is to the air knife. This is the changeover valve. This one here. Okay? We have maximum opening to the aseptic chamber, and here we have maximum opening to the air knife. This is production position. Big airflow. Okay? This here is stop. Maximum airflow after production to the air knife to keep it cool. You'll see these positions when we go through the step sequence in our program step-ups. You'll see these valves in different positions. And what you see on your pictures is exactly what's in the machine. Exactly. Okay? So we have two cylinders to operate the valves. Cylinder here, and these cylinders are monitored by sensors. So the position, we're always checking the position of these valves. So I'm at a comment here. Small hole to go. So small hole to prevent air heat, to prevent air knife heater from burning up during stop. So a small hole here. We push a lot of air this way. And here, as I said, valve homing check during preparation. So these are the main components. Okay? There's a lot of other pipe work and shit and stuff going on, but these are the main components on the sterilizing system. Surely I don't have to go through this. We've already done this last week. This valve is? Yeah, this one?
Steam valve.
This one?
Sterile.
It's sterilization valve.
Sterilization.
A sterilization valve and CIP. Heat, sterilization, CIP, product, steam. We went all over this because we went through all of this. Yeah.
Yep.
Remember? Okay. they're all the major components for the sterilisation system. All the major components. So before we have Smuggo, I'll show you a video of the pump, and then we push into a. Look it up. Good. So this is, and this is the only one we can find that actually looks like what we're doing. I've Googled this on so many pumps, but this is, so we use this one all the time now, even in the training centre. So you see here big air vent coming out and smaller air vent coming in. So this gap here is created by the water. So you see the gap here from the water seal out is much bigger, but the gap here between the water seal is smaller.